this video, we're going to talk about arc length and area of a sector. So arc length is really like circumference. Think circumference. And circumference, in case you forgot, is the distance around a circle. So that would be essentially like the perimeter of a circle. So arc length is saying how long is it if we start walking at W and end at Y. So this is going to be an answer that's going to end in, is going to have a unit of centimeters. To do this, we need to know the circumference. So the circumference is pi times the diameter. That's just the formula for circumference. So in this case, the circumference is pi times 16. And in case you don't know where I got 16 from, the radius is 8. That means the diameter all the way across would be 16. So if we're doing exact answers, we're going to do 16 pi. All right, and then for the arc length, so 16 pi, just to reiterate, is how long you would travel all the way around this circle. So this is 16 pi centimeters. If you were finding the approximate answer, you'd do 16 times 3.14, and that would give you how many centimeters it is. But we're going to do exact answers here. So arc length is going to be the circumference, but we're only dealing with this piece of the circumference, not the whole thing. And this angle here is 150 degrees. So what we're going to do is we're going to take the circumference and we're going to multiply it by a fraction, since we're not dealing with the entire circle and we're dealing with a little bit less than half. If this was 180, we just would take 16 pi divided by 2 because it'd be half, but it's not half, it's a little less than half. So to figure out how much of the circle we're dealing with, we're going to do 150 divided by 360. This gives us the fraction of the circle that we're dealing with. So our circumference is 16 pi times 150 over 360. So let me break out my calculator here and get this out of the way. We're going to do 16 times 150 divided by 360. And I get 6.6 repeating pi. So hopefully you understand that if we have 6.6 repeating pi, to write that a little bit more accurately, we would write, I mean, it's the same exact thing, but we typically write it as a fraction, 6 2/3 pi centimeters. So this is the distance. If you started traveling at W and walked to Y, that is the length of that arc. That's not to be confused with the arc measure, which is 150 degrees. That is how many degrees it is from W to Y. But if you're walking from W to Y, that would be 6 pi, or 6 2/3 pi centimeters. So that's the difference between arc measure, 150 degrees, and arc length. All right, the second question is, what's the area of the yellow shaded region? So I'll switch up to blue here. And it's a very similar idea. We're asking for area, and the area of a circle is pi times the radius squared. So the area is, in this case, pi times 8 squared, which would be, our exact answer would be 64 pi. And what that is the area of the entire circle. That's the yellow and white part put together. So I just want to know, what is the area of the yellow shaded part? Well, it's the same idea as what we did for arc length. We're going to take the area of the shaded, I'll write this down, area of shaded is the total area, 64 pi, times the fraction of the circle we're dealing with, 150 over 360. And I'll use my calculator again. So we've got 64 times 150 divided by 360. and I get 26 2/3 pi centimeters squared. So this would be 26 2/3 pi centimeters squared. I forgot my units on area. This is also centimeters squared. So for the area of a shaded region, we're going to take the area and multiply it by the fraction of the circle we're dealing with. So in general, how could we give like a rule for this? Well, if we have an angle of n degrees and a radius of r, whoopsie, didn't mean to do that. What would be the formula for arc length? Well, we said let's start with, I'll use L for arc length. I think most books use S, but that doesn't make any sense to me, so I'll use L. So the arc length would be the circumference times the degree n over 360. So this is one formula, which is very adequate. If you want to use radius in here, the circumference is 2 pi r, because 2 radiuses is the diameter, times n over 360. And this would be, either of these would be fine formulas for arc length on a circle. And for area of a sector, like the shaded region, same idea. The area would be the area of a circle, which is pi times radius squared, times the degrees over 360. So this would be our general formula for that. All right, hopefully that helped with arc length and area of a sector.